Greetings to our MOM lab lecturer. In this video, me and my groupmates will be presenting the lab works that we've done throughout the past few weeks. Each of us will be presenting one lab. That means there will be 5 labs overall. In every lab explanation, we will be talking a little bit about the procedures and defining some of the terms that we will be taking point of during the presentation, and we'll be discussing a little bit about the results that we've gotten. These are our group members, me, myself, and I, Christina, Sinwei, Natalie, Jovita, and Doris. Lab 1 will be represented by me, which is the shear force and shear stress in beam. Lab 2 is bending moment and bending stress in beam, will be presented by Lin Sinwei. Lab 3, deflection of beam by Jovita. Lab 4, buckling of compression member by Natalie. And Lab 5, mechanical properties of tension member by Doris.
This is Christina, matrix number AF210122 from Group 2 of MOM Lab. Today I'll be discussing about Lab 1, which is shear force and shear stress in beam. Now, shear strength is defined as the resistance of material to structural failure. Our main purpose of conducting this lab or experiment on the structural members is to determine the shear force and the shear stress of the beam at the cut section. At the condition of constant position of point loads, the shear force is determined by using different external forces. This experiment is executed by the given instructions. Hangers are placed at any position along the beam. The total number of 2 hangers that we use in this experiment. Configuration of mass on each hanger without exceeding a total weight of less than 300 grams. In engineering, shear strength refers to the resistance of a material or component to the kind of yield or structural failure that occurs when the material or component fails in shear. It is important in engineering design when characterizing the structural integrity of a bond between 2 surfaces, which is why it's important to accurately know the shear strength of a material, whether we're creating something to sustain shear stress or fail as a result of them.
Hi, I'm Lin Sinwei from Group 10 with matrix number AF210119. I'm in charge of Laboratory 2, which is bending moment and bending stress in beam. Bending moment actually is a mixture of the bending effect that can occur when an external force or moment is applied to a structural element. In this laboratory, we remain the position of the point loads for every 3 cases. The bending moment are determined using the different external force like 0.4905 Newton, 0.981 Newton, and 1.4715 Newton. Bending moment is important in structural engineering as it can be used to calculate how much bending may occur when forces are applied, and which may bend when loaded at any point along its length. Therefore, engineers can construct bending moment diagram for a building based on the probable stresses or load a building will experience. That's all for me. Thank you.
Hi, I am Jovita with batch number AF210088. I am responsible for the lab 3, which is deflection of beam. Deflection of beam means the movement of beam from its original location. The main purpose to conduct deflection of beam is to determine the maximum deflection of the beam. At the condition of constant position point load, the maximum deflection is determined by using the different external force. The real application of tension test is used for analyze the maximum deflection. Excessive deflection in building construction will cause jamming of door and window and cracking of plaster in ceiling. To avoid situation like this to happen, laboratory is used to set the limitation of not excluding the maximum deflection. Therefore, the deflection of beam is used to build up a safety building. That's all for me. Thank you.
For Mechanics of Material Lab number 4, we will be determining buckling of compression member. Buckling is actually sudden deformation of structural member. Specifically, in this experiment, we will determine the critical buckling load of aluminium strap. The critical buckling load will be represented by PCR. In this experiment, there are 3 different end restraint conditions that we will be using, which is pin-pin, pin-fix, and also fix-fix. There are also 3 different strut length, which is 370mm, 470, and also 520. Our main objective in this buckling of compression member laboratory is to apply the analyzation of critical load to withstand deformation of 3 different end restraint conditions. At the beginning of lab report preparation, we have calculated based on the standard end restraint conditions and also its Young modulus, as well as area of moment inertia. After that, we will do the experiment in the laboratory to determine the difference between the results. After obtaining the results from calculation and laboratory, we will compare it with graph displayed in our report. Finally, we will classify the compression member for each aluminium strut length using Euler buckling curve. From there, we can determine whether the strut has no buckling, undergoes inelastic buckling, or even elastic buckling.
Hello, I'm Doris Changing with metric number AF210093. I'm responsible for Lab 5, which is mechanical properties of tension member. Tensile strength means the maximum stress building can effort before failure. The main purpose to conduct tensile stress is to determine the ductility, tensile strength, and yield strength of structural members under uniaxial tensile stresses. The test shows the amount of elongation of the structural members until it rests. The information is very useful for quality control to make sure that the structural members is safe to use. The real application of tensile test is used for analysis the ability of metal to withstand tensile loads without failure. It's very important for quality control to make sure that the structural members is safe to use. After the outcome from the experiment is actually proven as a reliable finding, the structural members is confirmed can be used without safety hazard. So there is no worries about the structural members will break suddenly under constant force. That's all from me. Thank you.
In concerns of the results, there are slight differences. As you can see, for the first lab, the calculation and laboratory obtained results is a bit, there's a 0.01 difference. It applies the same to the second lab. In the third lab, you can also see the slight difference, which is in calculations and the lab obtained results. It applies the same to the fourth lab. However, for lab 5, there is no comparison between the manually calculated results and lab obtained results because it's simple calculations for as you can see here. In conclusion, based on the results that I've shown you, you can see that for the first, second, third, and fourth lab, the experiment obtained results and manually calculated numbers are more or less the same, with a slight difference due to multiple factors such as human mechanical error and so on. That is all for this video. Thank you for your attention.